Welcome to our YouTube channel, Local Teachers. Today we are going to discuss refraction of light at curved surfaces. So before going to discuss that, first we will try to learn what is refraction. So refraction is nothing but the change in direction of the light from passing one medium to another due to change in its speed is called a refraction. So for that, consider one example. So here we are considering two mediums. So here this is the interface. So this line separates the two mediums. So here we are considering water, and here we are considering air. Okay. So here these two are different medium. So consider, so the light is coming in this direction, in this direction. When it incident on the interface is nothing but which separates two mediums. So the edge line between the two mediums is called interface. So when the light is coming in this direction, when it incident on the interface, okay, so naturally, so if there is no, if it is in the same medium, it will go like this. If it is in the same medium, it will go like this only. But here mediums are different. So here what happens here, when it enters from one medium to another medium, so the light ray is refracted. That means the light ray direction has been changed. Why it is changed here? The speed of the light is different from one medium to another medium, so that when the light is passing from one medium to another medium, so the light will refracted, or the light is bended. So here this bending phenomena, so this bending phenomena is called a refraction. So simple words we can say that when the light traveling, or when the light is passing from one medium to another medium, so the light will bend. So this is called a refraction of light. If we want to know more about this refraction of light at curved surfaces, so here we have to discuss activity 1, which is given in textbook. Okay, so this is activity 1. So for this activity 1, so we need four materials. One is a cylindrical shaped transparent glass such tumbler. Next we need a paper, and we need a sketch pen, and we need some water. Okay, so in this for clear analysis, we are considering case 1 and case 2. So in the case 1, there is nothing but here, so we are considering one table. Okay, so on that table we are placing the tumbler glass, so which is in a cylindrical shape on the table. And okay, so on that paper sheet which we are considered, so on this, by using the sketch pen, so we draw an arrow. So it's is 4 centimeter. Okay, so here the arrow mark which is drawn on the paper, which is have 4 centimeter. Okay, so the same paper we are placing behind the mirror. So in what way we are placing the paper behind the mirror, such that so its arrow should be horizontal. Its arrow should be horizontal. Yes, we brought the paper and we place back of this cylindrical shaped transparent vessel, and we are observing from the other side the arrow mark which is drawn on the paper. So here basically its width is 4 centimeters, but when we are observed which is placed back of the mirror and we are observing from the other side or from the front side, so its arrow is looks like it is diminished. It is diminished. So here, so why we are getting this diminished image? Because here the reason is nothing but, so when we placed the paper back of the glass transparent vessel, so the rays which are coming from the arrow, which are coming from the arrow will refracted first this curved surface, again they will travel through that particular glass and it will enter into the air and it will travel, again these are refracted by this curved surface of the glass and it will passes through the glass and appears to our the rays will reach to our eye, so that we arrow seems to be diminished. But why it is seems to be diminished, that is nothing but here the rays here undergoes two times refraction. So by the refraction effect only the ray is seemed to be diminished. Okay. So while coming to the second case, so the same arrangement we are taken. So the empty vessel, transparent vessel, and we placed the same paper back of the a vessel, but here the difference is nothing but we are filled this vessel with water. We are filled this vessel with water. So here the arrow size is enlarged and it looks like a inverted image. So the size of the arrow is enlarged and it is looking as a inverted image. Why that arrow is looking like that? So that the same reason, by the refraction only. So how the refraction is takes place here? So the rays which are coming from the arrow first will touch the curved surface of the glass. So the light rays enter from air to the glass. So the refraction is takes place. Then it will enter into the water. Okay. So it will passes through the water. Again it will enter into the glass. So ultimately what happens here? There will undergoes a refraction. So after pass out from the glass, the rays will reach us to our eye. When we see that arrow, so it is enlarged and it is inverted. So we got here the arrow seems to be enlarged and inverted image. So why we are getting this type of images? So here by the refraction effect only we are getting in the first case the arrow is looks like a diminished image. So in that case that cylindrical shaped glass vessel is empty. In the second case, we filled that with water. For the same setup, the arrow seems to be enlarged and it is inverted image. So before entering into deeper discussion of this refraction of light at curved surfaces, we will discuss some important points. So further here consider two mediums, so which is have those are separated by a curved surface. So in this side I am considering water. So in this side I am considering air. So here this air is called as a rarer medium and the water is treated as denser medium. So here in technical or so these names are given. So for our clear identification, so one is rarer medium, the other one is denser medium. So here basically we know that how we got this curved surface. So this curved surface is nothing but it is a true part of sphere. So here if we extend, so like this we will get a sphere shape. So the center of the sphere is nothing but center of curvature. So the sphere center is the center of this curved surface. So here, so the midpoint of the curved surface is nothing but it is denoted by pole. It is denoted by P, that is pole. Okay. So if a line is drawn, so which passes through P and C. So this is nothing but principal axis. Principal axis. So the line which is passes through P and C is called principal axis. So how we are going to draw normal for this phenomenon? So that is nothing but here just consider a incident ray which is traveling in parallel with the principal axis. So which will incident at a point on the curved surface which is separating these two media. So just draw a line from the incident point to center of the curvature. So this represents, so this line represents normal for that incident ray, so which is drawn from the incident point to center of the curvature. So these are some points so regarding this topic.